So it's basically just a big induction coil receiver, and we've got a receiver that we borrowed from Dartmouth College.
I have 2 audio channels available, and they go up to 20 kilohertz each, so I think we're fine.
So if there was any electromagnetic noise, any electromagnetic sound, then in principle we should just be able, that should be a perfect audio track for to go along with the video.
Yes.
So it's worth a try anyway. Hasn't been done before. So.
It's exciting. That would be so neat, playing back those videotapes and listening to that soundtrack.
So this...
I myself have heard many eyewitness accounts. I've never heard it myself, but I'm convinced by the eyewitnesses that they're hearing something real.
Although Knudsen was able to deploy his extra-low frequency radio receiver, it failed to record anything, buried under meters of snow by the blizzard. He'll have to try the experiment again during next year's campaign. The team now turns its attention to their auroral cameras, hoping the weather will clear on their last night in Churchill. While they wait, the team monitors the data being gathered 1.5 million kilometers away by the SOHO satellite, which tells them about the weather in space and the likelihood of an active auroral display. Scientists like Knudsen depend on a network of space weather forecasting centers all around the globe.
And this is one example of an image.
David Bottler is the director of the Canadian branch.
Our mission here is to forecast space weather, which is produced by eruptions on the sun, throws out a lot of electrons and protons into space, and when they reach the Earth, they interact with the Earth's magnetic field, and that gives us magnetic storms on the Earth. This is a summary plot showing eruptions that have happened over the last few days on the sun. This is an active region on the sun here that is taken from an image on the SOHO spacecraft. This is one image showing a coronal hole on the sun, and from that region there's a constant stream of electrons and protons out from the sun. The reason we're concerned about this is because the magnetic storms and the high energy electrons and protons associated with them cause a lot of effects on systems on the ground or systems in orbit.
Human activity was first affected by space weather when early telegraph operators found their transmissions disrupted by peculiar power surges in the mid-19th century. As radio communication became the backbone of the modern age, the consequences of these disruptions became more profound. To this day, aircraft depend on radio communications at high latitudes since they fly outside the range of radar. Severe space weather can impair their ability to find their way. Incoming solar energy can also knock out power grids and cause increased corrosion in oil and gas pipelines. Outside of the Earth's atmosphere, satellites are vulnerable to the dangerous effects of space weather. Many of them have been disabled in this way, robbing millions of their telephone, pager, and television services. Future space travelers will have to understand space weather in order to venture safely across the solar system, since both the spacecraft and its human occupants may suffer from its harmful effects. The University of Calgary's Trond Trondsen and Eric Donovan are building a network of specialized cameras across northern North America.
Wow.
The pictures will help them to unravel one of the main mysteries of the aurora. how the processes in the upper atmosphere create a characteristic structure of large and small arcs, rays, and curls.
If you look up at an auroral display, if you've ever been lucky enough to be really underneath a very large active auroral display on a clear night, and you've taken the time to look up and see it, the structure that you're looking at is tens of kilometers across. And then you take a telescope and you look in it, and what you will see is structures inside that, little vortices and spirals and little filaments, and then you look at those and there'll be structure within those. And understanding what it is that causes the structure, that's more interesting, in my opinion, than understanding what it is that gives the electrons the energy. We'll sort that out probably in the next 5 years, probably completely. What it is that gives the aurora its structure, we'll be talking about that, I think, for decades to come.
Solving the riddle of the aurora's structure will take more than time. It will take the efforts of many scientific disciplines using a multitude of tools.
That's why we fly rockets through the aurora. That's why we fly satellites through the aurora. That's why we take optical images of the aurora on multiple scales. That's why we take images of the aurora from space. And that's why we have computer models and theorists and everybody else working on this. And I actually think it's a very interesting problem in general. And then it's nice because it's rich, it's multi-layered, and people can, anybody can throw themselves at this problem and find something interesting to them.
This is a high transmission dome. These weren't cheap. They were ordered specially from England. I think it was about 300 British pounds.
Okay.
It has 5 filters in the filter wheel, so you can look at 5 different wavelengths in the aurora. Green, the red, and the blue, and some additional wavelengths. I develop different kinds of imagers that study the entire sky from horizon to horizon, and imagers that study just a very small fraction of the sky, just to get a real close-up view of the aurora. Imaging the aurora is quite challenging at times, especially if you want to image it at high resolution, like I do, because you have to really zoom in on the smallest features in the aurora, and they move really fast back and forth.
The swirling in Tronson's video images capture the fine details of the aurora in near real time, something impossible for regular cameras. This will allow scientists to measure the large and small structures inside the aurora, an important step in solving the mystery of their origins. To help answer the other outstanding question about the aurora, how does the energy get fired down into the upper atmosphere? One needs to get above the aurora and observe what is happening from space. Space Agency's cluster mission is a group of 4 identical satellites that fly in perfect formation through regions of the magnetosphere where they can study the aurora up close. The satellites have been flying for 5 years, although the original launch failed 9 years ago. Luckily for the cluster team, the European Space Agency saw their work as critical and rebuilt the satellites from scratch.